Now we will review the RC cross-section data in the configuration rebar. The first thing we need to pay attention to is the container thickness, and this container thickness refers to the depth of the concrete section that I am working on. So now this section currently has a depth or thickness of 500, and this is the same number that we will find inside the properties of the rebar. The container thickness is 500. Of course, if we change the location of the directional point, we will find that the value of the container thickness changes, because the container thickness is supposed to be the concrete section that surrounds the configuration rebar I have. In the current case in front of me, I have drawn the rebar inside a rectangle, but we have an option here called rebar cross-section view. If we enable it, we find that there is a dot wrapping around my rebar. This is a representation of the concrete section that is drawn in front of me. So if we drag the directional point upwards, we find that it aligns with the rectangle we had drawn. So it is the true representation of the concrete section I have. I can hide or show it from the rebar cross-section view option here. In addition to changing the thickness of the concrete container I'm in using the directional point, I can also change it directly by entering a number. For example, if I say I want it at 500, it sets the height of my concrete to 600. Any number I start to enter, I find that my rebar begins to move accordingly. Next, let's observe the set of covers we have that surround my rebar. The first thing I have is the near cover. This is my cover from below, which is 30. Let's make it, for example, 50, because my cover starts to increase. Now I have a far cover, and this is the cover from above. From the direction of the directional point downward, we find that it is, for example, now 30. If we set it to 0, it will be flush with the surface of the concrete. If we set it to 70, for example, it starts to sink in more. So now we have the start cover, which represents the concrete cover from the start point on this side. So now it's at 30. Let's make it 70, for example, so that my section sinks in more from the side end cover, the part from the end point. Let's also set the cover here to 70. We'll find that my section now has a cover of 70 in all directions. Of course, if I enter negative values for the covers, my section will extend outward. So for example, if we go to the start cover and set it to 0, we'll find that it's flush with the face of the concrete. When we enter, say, 70 or negative 70, we'll see that it starts to move outward, and the same applies to the other side, as well as the bottom part, which is the near side, if we set it to negative 70, for example. And similarly at the top, we can also set it to negative 70. So in this way, we can also assign negative covers to our section. There's no problem at all. Next, we have something called reinforcement direction. The default setting is near, which means it draws my reinforcement or my rebar. The straight part is at the bottom. If I set it to far, you'll notice that my rebar flips. So this is a quick way to flip the rebar. In that case, my covers remain the same. Therefore, the distance at the top, or the top cover, is still the far cover, not the near. It remains the far, and the part at the bottom is the near, because the relationship between far and near is determined by the start point. The side towards the directional is the far, and the side toward the start and end at the bottom is the near. So here we can say this is a function that lets me draw things quickly. Someone might say, can I draw the bar flipped? Of course I can draw the bar like this. I set the start point, then I set the end point, and then I draw it flipped. There's no problem. In that case, the top part will be the near, and the bottom will be the far. So when I flip it, that's it, because it's about the relationship with the far. Now, the far is the side towards the directional point. Alright, so we can call this function something like flip direction. Next, we have something called keep rebar hook inside RC, wall and west bar hooks maxima. These are the last two items we have in the cross-section data. And to understand these, we need to open the rebar special data and look at an important property, which is the hook length, the start hook length, and the end hook length. It's the hook length or leg length, which is the distance of this leg. So we see that this distance is written as 440 on both sides. And we'll find that if we dimension this, it's the distance from this point here to that point there. So this is the value of 440. It measures it from the bottom face of the rebar up to the top face of the rebar. This number, of course, is calculated, or there's a number I have, and we'll explain this inside the data. There's a maximum value. Why? My maximum depends on the container thickness that I'm in. It takes the container thickness, which in our case is 500, and subtracts the near cover value, which is 30. Then it subtracts the far cover, which is also 30. So this becomes the value of the maximum hook length. And we find that it's calculated here in our value. So we find that we have a maximum at the start and a maximum at end. Alright, if I start entering a start hook length value, let's say now, what do I want? For example, 200. We'll notice that the height of my rebar decreases on the start side. If I go to the other side, I can say no, I want it to be 300. So now I have a height of 300 on one side and 200 on the start side. To make sure, let's take a look. We'll find that the leg length here is indeed 200, and surely over there the length will be 300. So this is the first relationship, which is the relationship leg with the container thickness. Okay, now if I enter leg by 500, you'll see that it doesn't accept it and sets it to its maximum value, which is 440. Why is that? That's because we have constraints. So when I enter a value of 500 or 700, it always sets my hook value, or the maximum value I have, which is 440. Now here we see the first constraint we have. Keep rebar hook inside the RC section. So now let's say I keep the hook or my value inside the concrete section. So when I enter a large value bigger than the clear of the section, it doesn't accept it and sets the height of the hook to the maximum. But suppose I want to extend dowels, for example, or I want this to go outside the concrete section. All I have to do is change this option to no. Don't keep my section inside the concrete. At that point, when I enter leg length greater than my clear length, you'll find that it accepts it normally. So let's say, for example, I want it to be 700. You'll see that my leg actually became 700 and extended outside the section. On the other side, I can also tell it, for example, I want it to be 900, and you'll see the same thing happens. It extends outside as soon as I change this option to no. They'll go back again to holding their maximum, which was 440. As we said, it is the clear height we have available. So here we find the first value I have, which is keep rebar hook inside RC. Now I have always set rebar hook to maximum. What is the benefit of this if I set it up? Let's talk about it now. No, its drawback is that if I change concrete dimensions, for example, using the grip or using the property, I said that I want it to be, for example, 300, so I find that my section actually gets smaller. So when the section gets smaller, we find that indeed the values of my hooks get updated, and it says that your length is now 240 because it replaced your maximum. But the problem happens if I increase the section, if I make the section bigger, whether from the point or from what I have, I find that the height of the hook stays the same and doesn't change. So why is that? Because now it's set to always set rebar hook to maximum no, and don't always make it maximum. So what happens? When I reduced the section earlier, it was forced to respect the height of that section. It had to do it as long as I had the keep rebar hook inside RC option enabled. But when I started increasing the section, now the rebar is drawn correctly, right? All that happened is that it didn't follow the new maximum height so that it wouldn't change the value I already have. So I have to change these numbers manually, entering values like 300, 350, and so on. And of course, if I enter a number greater than my section height, it will maintain my maximum height. But if I use always set rebar hook to maximum command and set it So I always find that no matter how I move this up or down, or even if I change my cover manually to say 500, I always see that my hooks changes automatically with whatever change I make, whether it's less or more. So we always find that the hook down value changes with me. The only drawback is that if you try to change this number now, it won't let you because it is always keep set rebar hook to the maximum. So always keep it at the maximum. My maximum clear height will always be the maximum clear height. That's why we set it by no in case someone wants to change the hook value and it doesn't change for them. So they don't think that this number is broken or that it just won't change. No. The reason it doesn't change is because you choose always set rebar hook to maximum that way. So sometimes it's useful and sometimes it's not. So we need to pay attention to the settings for set rebar hook to maximum and keep hook inside RC.